Jon.
I'm David.
And we're here to talk to you today about concrete.
Yep. Is this our first time?
This might be. No, but it's definitely our first time talking about
These guys.
the Q-tips. So we're here to talk about the stress.
Just wanted to show you this one.
Ready?
Yeah. So we're here to talk to you about the stress and strains of concrete.
Good, John.
Thanks, David. And David, why is stress important for concrete?
Well, stress is important. As we came through the decades and the ages, we learned that stress is on a unit basis. And so theoretically it's independent of geometry. So if you're a little, I'll do my little stupid clown pantomime, if you're a little cube, you know, or if you're a great big column.
Or an arbitrary German potato in
Or-
space.
That too, since you're on a unit basis, that, you know, it's geometry independent. So
Right.
that's basically what's important about stress.
And for you junior engineers out there, if you're just going through your ACI 318 and your reinforced concrete class, we learn about stresses from our uniaxial compressive strength that we have to take into account for certain calculations, our F prime of C, and then eventually our F of R, our modulus of rupture.
Right. Well, as you suggest, we take a cylinder and we break it, the C39 test, uniaxial compression. It tells us at what load and therefore stress that the concrete breaks. And the design principle in the old days, the elastic principle was we went to a certain limit below the failure stress, the strength. Failure stress is strength. So in the elastic idea, we stayed well below that. Then we switched to the load factor design idea that we work on the load side and we would increase the loads, factors of safety through the loads, and let us design up to the ultimate strength in that case.
So now we see why stress is important, but something that I've been learning over the last 4 years, 3 years, 4 years?
Yeah, lifetime. Yeah.
Lifetime. Strain is equally, if not sometimes even more important.
Well, yeah, you know, why does a crack form in concrete? Well, it's strain, isn't it? In the end, it's strain that does that.
Yeah.
So on the graph, we've got stress and we've got strain, and so we plot a line that represents the failure surface, either in stress or strain. But in a practical manner, if when we're in the field and we want to know something, I mean, if you think about a ruler, it's easy to take a ruler and measure something.
Right.
So it's hard to take a bathroom scale and measure something.
Well, you can measure your weight.
You measure weight, but the point is that it's way easier to measure length or change in length in the field.
Right. Oh, absolutely.
Right.
Absolutely. So how do we go about doing that?
Well, we have these handy devices that have been around for a very, very long time, known as strain gauges, because they gauge or measure strain. Pretty simple. So this is the most common strain gauge. You can see, John, it's just this little tiny red strip here. This is for metals, to put on metals.
Okay.
And the principle behind a strain gauge is there's a wire that wraps around and around and around and around and around to make it long.
Right.
So we know that if we take a wire and we pull it,
Right.
it gets longer.
Right.
And we know if it gets longer that the electrical resistance is greater.
Absolutely.
So that's basically the principle of the strain gauge. We want to measure the change in resistance as it lengthens.
So this is a resistor.
Essentially, this is a resistor, yes.
I learned something, huh?
So this is a strain gauge for applying to the outside of concrete cylinders. And why do you suppose it's so much bigger?
Well, because concrete is a pain in the butt.
Well, there is that. But we don't want to glue a strain gauge to the outside surface and just measure one rock.
Right.
So we need sort of an averaging technique, and that's why we have these longer strain gauges. And if we want to put a strain gauge inside of concrete,
These are my favorite.
inside of concrete we have this device, and you can see that you throw it in the concrete, and it's got these two little ports so that as concrete swells or shrinks, it moves these two ports and produces a strain measurement for
I
us.
love these. I call these the Q-tips.
Yeah, so there's these come in various forms. This is a more short term. They come in a different design for
Right.
long-term, essentially life of concrete.
Is this the vibrating wire one?
No, this is a resistance gauge.
Okay, wow.
Yeah, this
So
is,
same concept as these.
it's basically the same concept. Yeah.
And this one we've used, correct me if I'm wrong, we used this one and we were able to map the strain close to the heat of hydration or the temperature hydration curve within first 24 hours.
Absolutely. We use those in cylinders,
Right.
and we saw, well, obviously, if something heats, it's going to get larger. If it cools, it's going to get smaller. If something's strain, if you get greater strain, it's going to strain, it's going
Right.
to strain larger and strain less. So there's a clear relationship between temperature and strain.
This is wild. This is absolutely wild. So where do we use this stuff? Why do we care?
Why do we care? Well, you know, if we're doing new things, then we need to measure and know what we're doing. The problem is, we don't know what we don't know. So,
It's one of David's famous lines.
It's one of mine, yeah. So if we're doing something we've never done before,
Sure.
a new material, or we're out in the field in a new situation, then we can measure the field situation
Right.
with the strain gauge and learn what's going on. If we're in a problem area, you know, we're anticipating problems,
Right.
then we're going to do a pavement in a soil that might be less beneficial, that
Sure.
kind of thing. Or if we're in critical structures, we're in a high rise or a water tank or a dam or something that's really critical, that's, you know, we need to know what's going on over the long term,
Mhm.
then we're going to put in a measurement system, a monitoring system to help us keep track of what's going on over the long term.
And David, correct me if I'm wrong, didn't you develop a wireless strain monitoring system?
We have, well, develop's the right word.
Yes.
Yes, thank you for that. So this, to a civil engineer, we have this, the classic black box. And the strain gauge itself, you see it mysteriously ends with 3 bare wires.
Right.
You know, so, you know, do I put my fingers on the bare wires? No. Do
No,
I
no.
touch them to my lips?
No.
I don't do any of that. We need a way to energize the strain gauge to put the resistance through, so we can measure the change in resistance.
Sure.
So this lovely black box has a number of ports that we can install the wiring in, and through electronic engineering magic,
Magic.
absolute magic, it will read the difference in the strain for
Right.
us, difference in the resistance for us,
Okay.
and then we can convert that to strain. And this particular device, what's nice about this particular device, John, do you see any cords or?
No.
No.
Love it.
No, it's a German potato in space. It's a black
Arbitrary.
German
German
potato.
potato in
It's a
space.
black box in space, and so we can hook the wires to it. It has batteries on board, and we see this very large black finger-shaped object, and we know what that is, right?
It's an antenna.
It's antenna. Well, all right. Well done, John. Yeah.
I deserve it. I'll
Yeah,
take it.
well
Take
done.
it.
You know, I didn't know you were an expert in electronics.
I don't want to brag, but sometimes I need to. Sometimes.
Yeah. So what this will do, it'll read the change in resistance. It'll tell us that, and through the antenna, it'll transmit it up to half a mile.
Wow.
And we can sit in our office or our truck or our construction trailer or whatever on our laptop, and it'll just send it to us. We can watch it real time. We can set various ways for it to read. We can set it to read over a very long time, very short time.
Well, for the long time though, we'll need a different
Right. This
strain gauge. Or
this is from Texas Measurements, and again, we don't necessarily endorse products, but sometimes we mention products that we're familiar with.
sure.
Texas Measurements is run by my mentor from Texas A&M, Dr. Harry Jones,
Sweet.
and he and in the research at Texas A&M, they've used these in piles and various
Right.
things, and they've had success with them probably up to a year or more. So there's, you know, something on that order. They're really designed for cylinders. They're designed
Sure.
to like 28 a day and that type. But probably up to a year. But as you know, there's a different design that's
Mhm.
designed for lifetime that looks different from this.
Well,
The plastic's more rugged and whatnot.
And then I did see some of them that you could set up in certain configurations to understand how the concrete is moving.
That's right. All of these are one-dimensional.
Right.
So you can imagine it's going to move this way. If something happens this way,
It won't see it.
it won't see it.
Right, right, right.
There are three-dimensional strain gauges made, but yeah, all the ones we're talking about today are all one-dimensional. So as you suggest, if you wanted to measure in three directions, you just simply put three of these
Sure,
in.
sure,
Put
sure.
three of these in. You can put them through your black box in space and read the three different directions.
I'm pretty excited to get to work on these bad boys.
Yeah, so a good example would be a beam. You know,
Mhm.
if we wanted to know the flexural strain in the bottom of the beam, we mount it this direction. If we were up over the abutment and wanted to know the strain due to trucks or
Right.
pressure, we mount it in this direction.
So theoretically, could we put, if you're looking at a single reinforced concrete beam, and this is the bottom of your beam, boys. Oh, here we go.
Here we go.
So if you had,
Here's a beam.
so if you had your beam right here, could you put strain gauges, let's say 1, 2, 3, 4, and maybe even one on the neutral axis, and you should be able to map your strain
Absolutely.
as you would draw it out.
Absolutely. And as you talked about first about reinforced design, you recall we have the strain block
Right.
that by ACI is limited to double naught 3 and whatnot. So,
Sure.
so we can actually measure that in the field.
We can measure that here.
We can measure that in the lab. Sure, measure it here in the lab.
Talk to resources.
And
We gotta do that.
yeah, we could do that. And if if you're doing unusual designs, if you're doing arch beams or
Sure.
things like that, that's probably worth measuring. And so the first time you got a monitoring system, the next time you have improved design because you know at what strains you've exercised your structure.
I think it would be fun just to do that in the lab,
Yeah,
to see the system work.
yeah, we could do that.
Okay, I have to jump back in there. We've got more mixes to do.
Okay.
Thank you very much. Thanks for joining us today. Hopefully you learned some. Don't forget to like and subscribe. Ding that bell for notifications. Go Concrete!
Beat ass live.